Now, the last lecture in this series, and I'm going to give you some examples. So I'm going to kind of run through the lecture part a little bit quicker, but that's adjustment factors. And remember, we had our breeding values where we had our observation minus our mean, and then took that and times our heritability. But here's the problem. There's various factors there. We don't know which one was born. You run them all into the pen, and the biggest one stands out at you, and the little one stands out as being the cull. And so when you're just observing them, you look like this one's a keeper and then that one's a cull. And so what you end up with, though, we've got to make some fair comparisons, because some of those, that great big one may be the oldest one in the group, and then that youngest one in there may be younger by 2 or 3 months. And if we're talking about, a 2 to 3 month difference, and you're talking about 60 to 90 days. And so that can make a huge difference. So without us taking away, without us making an observation, we can't really tell the difference. Other thing is, too, is age of dam. Hey, do you expect that first calf heifer, or you expect that yearling ewe on her first parity or first offspring to be as good milking and lactating as a 4 or 5 year old cow or a 3 or 4 year old ewe? Probably not. And so we're going to have some variation due to age of dam. Once she gets in production multiple years, then it kicks that milk factory into shape a little bit quicker, gets her into production a little bit quicker. And so we have those advantages. Age of the individual, we just talked about. We can have anywhere from a 2 to 3 month on a 7 or 8 month weaning in cattle and sheep and goats. Guys, we could have as much of a 15-day difference on strictly 60 days. So that's a huge difference in terms of time if they were born early or later. Other thing is, too, we start talking about for hogs, litter size. Big difference if she's only got 6 babies versus if she has 16 babies. And so it's not going to be a level playing field for us in terms of quality and size and growth, for us to make accurate comparisons on our bell-shaped curve. The adjustment factors don't account for variations in environment. They do account for known variations. So if we have a drought, we had a hurricane this year, these adjustment factors, it's not going to affect it a year to year like our repeatability. We're just going to be able to use those adjustment factors within this contemporary group or this population. So, boom. What we're looking at, guys, we're wanting to increase the heritability, okay? And we're trying to reduce this environmental component that we know about. But the permanent ones right here, they come back to that age of animal, age of dam, etc. I also posted a Word document with known sources of environmental error and variance. And so I suggest you pull that down, give it a glance. So 3 main factors, and I want to probably say, throw a big star there. Reduce environmental variance. And so when we reduce that environment, and if you think about our heritability, if we take more out of the denominator and get this number smaller, then it's going to increase the amount in the top. And by doing that, we're going to see an increase heritability. So we're sitting here reducing the numerator. We're trying to put things on more of an apples versus apples or oranges versus oranges comparison. And by increasing heritability, we're in essence going to increase selection. So we talked about those highly heritable traits: growth, mature size, rib area, muscle, those all being at 0.6 or better. And we said we could change those usually in about 1 generation. So those that are very lowly heritable is going to take a lot more time. So 2 different types. We can either add in numbers, others, or we can multiply numbers, and we'll show you examples of both. Beef Cattle Guidelines, Beef Improvement Federation, and what you had was birth weight. And here's the thing, you got a real young female, she may not weigh but 1,000 pounds dripping wet. She's going to obviously have a lot smaller baby. And so for you to get an accurate number, you have to sit there and add 0.8 pounds. So if she comes out with a 60-pound baby as a 2-year-old, then for you to do it as an adjustment, you're going to have to add that 8. And that's going to say that it was more likely a 68-pound one. And so the advantage there too, you can say, but I want it to be lower. Yeah. But if you're going to sell that as a bull to somebody and they think it's a 60-pound deal and not realizing that it's adjusting up. Okay. And so technically it's a little higher, then they have a decision to make. 5 to 10, normal. Boom. We expect her to be in production. This isn't her first rodeo. Life's good. Weaning weight. And here's the thing, guys. Don't worry about all the details here. I'll get it to you later. But what we end up with is an adjusted weaning weight or an adjusted 205-day weight. And most good producers are going to follow that adjusted weight more than they are the accurate one. And the thing is, you can end up with people that put a creep feeder out. You got babies or you got offspring that spend half their time eating feed versus drinking milk, and you get some value that's blown up. Okay. So all we're doing here is we're just figuring out an average daily gain. So we're figuring out age at weaning, difference in that. Boom, multiply by our 205 to get an adjusted. We add our birth weight back in. So all we did is we took the weaning weight from that day minus what they came out of mama weighing, divided by the number of days, times 205. And this gives us an opportunity to take animals that are maybe 265 days old and bring them back down to what they would have been at 205. And animals in there too that were only 180 days old and weren't even there at 7 months of age, and it adjusts them up. Boom, some other additives. And here's the thing. This right here comes to milk. So a younger female is not going to be at max peak production. She herself is still growing, utilizing nutrients. She gets to 5 or 10, that should be pretty steady. And once she gets over 10, you're just kind of on borrowed time. So we get a slight adjustment there up because she's probably not at her peak performance like she was when she was 5 to 10 years of age. Yearling weight, don't worry about. We'll come back to the details later. Most of them are going to be adjusted to yearling, 365 days. Hogs, National Swine Improvement Federation. And what we have here, guys, is parity. And parity is the litter. So her first litter, she gets an adjustment factor here, 6.2. Her second litter, she gets none. Third, 1.0. By now at her fourth litter, though, you know, this is a year, 2 years, about 2.5 years of age. She's starting to get a little old. So here she would be in a typical deal, hopefully at about 3 years of age on her fifth. And she's starting to get it. And the thing is, guys, those sows, a lot of times production numbers, you name it, starts to go down considerably after they're about 3 years old. 21 days. Reason is we tend to wean or take them off of mama at 21 days and get her back into production. Boom. Newer recommendation. We've talked 250 pounds is where we're going in terms of weights. Days to 250. And don't worry about it. We'll get into some detailed stuff later. National Sheep Improvement Program. We've got adjustments for age. We got adjustment factor. And a different thing here is because we can have multiple births. So if you've got a set of twins, they're going to be smaller. That's less milk per animal. You got a big single in there, and that single gets to go off of both teats and rock and roll in terms of production. So, cool thing, make sure, guys, you're able to read these, interpret these numbers. If it's a ewe lamb, and the first thing is, this right here is if it's female lamb. So you got to know the sex of the animal. This right here is if it's a male. Okay? So ewe lamb, ram lamb. Then we've got splits for age of dam. So the one right here that's ideal, 3 to 6 years of age. these are going to get the least adjustments. So if you look, 1.0, 1.08, 1.13, this right here is for a yearling, and this would be for her first lamb. She has it as a yearling. And right here, age of dam. If she's 2, she's still not expected to be in peak production, or if she's already over 6. And so that's the thing, guys. We're 3 to 6 years old here. We're 2 years old or over 6, we're going to get a slightly different adjustment. And so what happens is we come out with a twin, but that other lamb dies off, then the lamb's raised as a single, so it's getting more milk, more nutrients, all right? So we figure them out. We're going to have to come and look at this table and determine the multiplication factor needed for each of those classifications. So, boom, we got to do the sex of the lamb first. Top set of numbers, bottom set of numbers. Let's see, sex of lamb. Second, we have to have age of ewe, so we know which column. And then thirdly, we have to know the type of birth and the type of how they were raised. So if it's a twin raised as a twin, there's your set of numbers. Boom. Figure out your age, you know exactly which number it is you need. Adjustment factors. Better make sure you know this. We increase heritability because we decrease our numerator or environmental effects. We adjust them to a common number, so that gives us a better idea of how to make those decisions. And anytime we increase heritability, we're also going to increase response to selection.